How does a robot know how to get to its destination? One way would be to get a person to guide it. This was what you did when you had the joystick connected to your robot. A second way is to get the robot to work out its own path based on information from its sensors. This is what happened in Activity 7 when the robot was confined to an area by the black line perimeter. A third way is to provide a path that the robot can follow. For example, the robots in this factory are made to follow wires buried in the floor to go from one location to another. Robokid has the capability to follow a black line. You will remember using the two front infrared sensors in a previous activity. Well, this time, Robokid will use them to detect when it has moved away from a black line. Here you can see the robot following a black tape line. Your teacher will give each team 3 sheets of paper that should be taped together to form a test track. Just as I'm doing here, use the lettered arrows A and B to position the 3 sheets. Use small bits of clear tape to make one large sheet. Use small strips of black tape to cover these gaps. Here's the completed track. You may have to tape these sheets to the floor to stop it moving about when the robot runs. For this first set of experiments, you need to put your robot into mode F0. After power on, press switch A, then press switch D 3 times, and finally press switch A twice. Place the robot on the line. Make sure that it is placed with the 2 sensors at either side of the line. In mode F0, you can use switches A, B and C. Switch A is a start-stop switch, switch B reads the pots, and switch C causes the robot to exit the F0 mode. Press switch A to start. Notice how the robot follows the line. Lift the robot and press switch A to stop. It seems quite clever. How does the robot do this? Here's a simple animation to show you how it works. If the 2 sensors do not detect the line, then the robot keeps going in a straight line. As soon as one of the sensors detects a line, it stops the wheel on that side of the robot. In this example, the left sensor sees the line, so the left motor is switched off, and as a result, the left wheel stops turning. The effect is to make the robot turn to the left. It keeps turning until the sensor no longer sees the line. When this happens, the robot starts moving forward in a straight line again. The way the robot is behaving can be described with a flowchart. A list of problem-solving instructions like this has a special, odd-sounding name. It's called an algorithm. Quite a mouthful. The word comes from a 9th century math document. Considering we live in the 21st century, it's really old. The engineer who built Robokid had to work out the algorithm for line following and convert it into instructions that could be run by the robot's computer. The algorithm instructions are written in a special computer language which is a bit like English but with extra rules. This is the same language that describes the algorithms in your iPods and mobile phones. Okay, enough theory. It's time for some experiments. If you adjust the pots, you can change the way the robot follows the line. Pot 1 is used to change the speed. Pot 2 lets you change the way the wheels behave when the line is detected. Remember earlier we showed you that when the robot detects the line, it stopped one of the wheels. Well, you don't have to stop the wheel, you can just slow it down. Pot 2 lets you adjust the amount of this slowdown. The robot is constantly checking if the front sensors see the line. There's a time delay between the checks. By setting pot 3 to its 12 o'clock position, there will be a medium time delay between these checks. For these experiments, you'll be setting pot 3 to a fixed point and varying pots 1 and 2. For the first experiment, set the pots as follows. Pot 1 to its 10 o'clock position, pot 2 to its 1 o'clock position, and pot 3 to its 12 o'clock position. Now run and observe what happens. Record it on your worksheet. Remember to press switch B to get the robot to read the pots. Press switch A to start. For the second experiment, set the pots as follows. Pot 1 to its 10 o'clock position, pot 2 to its 11 o'clock position, and pot 3 to its 12 o'clock position. Now run and record your observations on your worksheet. Other experiments are explained in the worksheet. As a team, work together to complete them. Always remember to press switch B to get the robot to read the pots.